learnt about resistance. We learned what is resistance. We learned how resistance is related to voltage and current. But when I talk about only resistance, what exactly is resistance? Resistance has an SI unit of ohms, which is written like this. Okay, and resistance is directly proportional to the length of the conductor. Resistance is indirectly proportional to the area of the wire or the conductor. And resistance, there is one more factor, that is material of the conductor. Okay, so if I want to relate all these three things into a formula, I can write that resistance is proportional to L by A. Now, when I equate it and get it into a equation, there has to be a proportionality constant, like always in physics. So, R will be equal to rho L by A. So R is equal to rho L by A. So what is this rho here? This rho is known as specific resistance, or you can also call it as resistivity. This resistivity is different for different materials. So this is how resistance also depends on the material, what type of material it is. And one more thing, that resistance also depends on the temperature of the conductor. So these are all the factors that are there. There's one more concept where you can remember the factors of resistance. This is a very simple example. Let's consider we have a highway which is longer. This is shorter, but they have same thickness. Now I'm just going to draw a few cars that can be moving on this highway. Okay, if you look at these dots that are there, these represent the cars on the highway. If you see, the longer highway can accommodate more cars in it, more traffic, so that means it has more resistance. So that is why we say that resistance is directly proportional to the length. As it is longer, there will be more resistance, more cars, more blockage, more traffic that can be there. Now, on the other side, there are two highways of the same length but different thickness. One is narrow, one is broad. Okay. So if I start drawing cars on it, now let's look at one which is a narrow highway and the other which is broader highway, but their lengths are same, exactly equal. So that means this has a lesser area and this has a greater area. Now I've drawn few cars for you all to watch. If you look at it properly, if the narrower looks, traffic is more here and traffic is less. There is a lot of space here. So what does this mean? There is more resistance on this one and there is lesser resistance on this one. So this exactly denotes what? That resistance is indirectly proportional to the area or the thickness of the wire. And this is the easiest example for you all to remember the factors and not get confused. I also told you that resistance depends on temperature. Okay. Now let's consider a VI graph, not IV graph. VI graph. And I'm drawing two conductors. Okay. The first one is, let's say, conductor A, conductor B. Conductor A has a temperature T2 and conductor B has a temperature T1. So T2 is greater than T1. So temperature of the first conductor A is greater than the temperature of conductor B. Now if I consider the slope of this graph is going to be V by I, like Y over X. So that is nothing but your resistance. So what does that mean? The conductor A with a higher temperature has greater resistance. So that means that higher the temperature, higher will be your resistance. Now we learned the formula for resistance as R is equal to rho L by A. What is specific resistance? What is the formula of specific resistance? You can just rearrange the formula and write it as R A by L. So this is the formula for specific resistance. When I want to get the unit of it, how do I get it? I can say rho is equal to O meter square over meter. So this gets cut and you get specific resistance unit as ohm meter. There's one more quantity that you should be knowing, that is known as conductivity. What is conductivity? Conductivity is nothing but reciprocal of resistivity. So resistivity was what? Resistivity, what we found out was RA by L. So what will be conductivity? Conductivity will be L by RA. And if you want to get the formula, so you can say meter over ohm over meter square. So now here the formula, the SI unit will be ohm inverse, meter inverse.